Once ridiculed and buried under waves of skepticism and delays, the Tesla Semi was thought to be doomed in the so-called production hell. But now, Tesla Semi is entering a golden era, with plans to produce 50,000 electric trucks at its new Giga factory. Not only has Tesla broken through every barrier, but it has also unveiled the most unique truck production line on the planet, where a single Semi can be completed in just 10 minutes, an unprecedented feat in the industry. With a price tag of $250,000, the Tesla Semi may seem like a hefty investment, but the savings in fuel and maintenance costs are expected to quickly pay for themselves, making it an irresistible option for logistics companies. Following a series of successful test runs, Tesla announced that the new Semi factory will be running at full capacity by the end of this year. Elon Musk confirmed that anyone can now purchase a Semi truck with customizable configurations, allowing customers to tailor their trucks to their individual transport needs without breaking the bank. This is how we believe Tesla Semi will redefine freight transport across the U.S., both for large fleets and small businesses alike. So, what makes Tesla's mass production plan for the Semi so special? And when will Tesla officially open orders for external customers? We're about to reveal that now. In the world of heavy-duty transportation, where 18-wheelers dominate long-haul routes, the idea of a fully electric truck was once considered impossible. Even billionaire Bill Gates once claimed that electric batteries were too bulky and heavy to meet the demands of giant machines like the Tesla Semi. But Elon Musk fired back, saying Gates didn't know what he was talking about when it came to electric trucks. Musk boldly asserted that Tesla could build a Class 8 electric truck capable of disrupting diesel entirely, with performance specs that would shake up the entire industry. Elon Musk has repeatedly pointed out that diesel trucks account for only 1.1% of vehicles on the road, yet they produce a staggering 16.4% of all transportation emissions in the U.S. That's a truly alarming figure. As the world's leading electric vehicle company, it would make no sense for Tesla to rely on diesel trucks to transport parts, machinery, and powertrains between its factories to build electric vehicles. It would be even more ironic to use diesel trucks to deliver electric cars to customers. That's exactly why the Tesla Semi was created. When Tesla first unveiled the Semi in 2017, the trucking industry laughed it off. A fully electric truck that could haul 80,000 pounds, accelerate from 0 to 60 miles per hour in 20 seconds, and travel 500 miles on a single charge? Even the most optimistic observers thought it was a pipe dream. The project faced constant delays, missing the original target of mass production in 2019, and only trickling out a few test units in 2022. Battery supply chain issues, a complex design, and the immense challenge of scaling up manufacturing all contributed to what Tesla called production hell. As of the end of 2024, only about 300 Tesla Semis had been built. Over half of those were delivered to major clients like PepsiCo, Costco, and Walmart, while the rest were being used internally by Tesla. 2025 marks a major turning point for the Tesla Semi. With a $3.6 billion investment, Tesla's expanded Giga Nevada factory is now ready to take the Semi into full-scale mass production. According to Elon Musk, the new facility, featuring an additional 4 million square feet, won't just build the Semi. It will also integrate an on-site battery production line, eliminating the delays caused by transporting batteries from other factories. This vertical integration allows Tesla to achieve unprecedented manufacturing efficiency, a fully assembled Tesla Semi every 10 minutes, which equates to over 135 trucks per day, pushing toward the goal of 50,000 units annually, starting by the end of this year. Building a heavy-duty electric truck like the Tesla Semi in just 10 minutes sounds like science fiction, and we were skeptical too. But it seems Elon Musk has once again made the impossible really. The new Giga Semi production line features mind-blowing automation, especially in the frame stamping process, which is handled by some of the most advanced machinery in the world. Even though the Semi is Tesla's most complex vehicle to date, due to its massive size and high customization requirements, the factory leverages cutting-edge technologies like high-speed robotic assembly and a just-in-time conveyor system, which Musk once called a factory of the future. What makes the Semi production line unique is its integration. Giga Nevada not only builds the vehicles but also builds the batteries on site, using a new type of high-voltage battery that is cheaper and more efficient, despite its smaller capacity. According to Dan Priestley, Semi Program Manager, the batteries improve energy efficiency by more than 7%, allowing the Semi to maintain a range of 500 miles without adding weight. Producing the batteries on site reduces reliance on outside suppliers and shortens assembly times. The result? A Tesla Semi can roll off the line in just 10 minutes, paving the way for a target of 50,000 vehicles per year. Compared to competitors like Kenworth and Peterbilt, which will sell a combined 190,000 Class 8 trucks in the US and Canada in 2023, Tesla's 50,000 target is a strong start. But Musk isn't stopping there. Believing that with continued optimization, the Semi factory could eventually produce one car every 5 minutes, a rate that would surprise even industry giants. At $250,000 for the 500-mile version, the Tesla Semi isn't cheap. PepsiCo, one of its first customers, used $4.5 million in subsidies to buy 18 Semis, suggesting that the initial cost is a major hurdle. But Musk didn't call the Semi a money machine for nothing. The Semi's low operating and maintenance costs make it a superior long-term investment. Take a look at these numbers. The Tesla Semi consumes 1.7 kilowatt-hours per mile, which translates to about $0.30 per mile in California. In comparison, a diesel truck burns through about $3.51 every 6.5 miles with 1 gallon of diesel. With an average of 100,000 miles driven per year, a Tesla Semi saves tens of thousands of dollars in fuel compared to a diesel truck. As of September 20th to 24, the Semi fleet in North America has already saved over 1 million gallons of diesel, roughly $3.5 million, despite having only around 300 units on the road. Scaling this to millions of trucks would result in massive savings. Maintenance is another major advantage. With costs around 10 cents per mile, the Tesla Semi cuts maintenance expenses in half compared to diesel trucks, which average 20 cents per mile. Over 5 years, a driver logging 100,000 miles annually would spend just $50,000 on maintenance for a Semi, compared to $100,000 for a diesel truck. Regenerative braking that never overheats, along with a minimalist design that eliminates internal combustion engines and complex transmissions, reduces downtime and maximizes transport efficiency. The Tesla Semi isn't just cost-effective, it's a beast on the road. With 3 independent motors delivering instant torque, the Semi accelerates from 0 to 60 miles per hour in 20 seconds, even when hauling 80,000 pounds, and it can reach up to 800 miles when running empty. The regenerative braking system in the Tesla Semi recovers nearly all the energy during downhill driving, extending the vehicle's range and reducing the number of charging sessions needed. In a real-world test during the 2024 Run on Less event, the Semi set a record by covering 1,076 miles in a single day with just 3 fast charges using the Megacharger network. This demonstrates that the Semi can truly replace diesel Class 8 trucks on a one-to-one basis, shattering long-held assumptions about electric trucks. Major customers like PepsiCo, DHL, and Saia have confirmed this performance. Saia, a logistics company with over 100 years of history, tested the Semi and recorded energy consumption of just 1.73 kilowatt-hours per mile. Drivers reported a smooth, comfortable ride and praised the truck's ability to maintain speed on inclines. PepsiCo drivers went even further, saying they only want to drive the Semi now thanks to its quiet, low-stress driving experience. The Tesla Semi is about more than performance and savings. Elon Musk has confirmed that full self-driving capability will soon be integrated into the truck, with deployment expected by the end of 2025, aligning with the start of mass production. Full self-driving isn't just a tech feature, it's a solution to the ongoing truck driver shortage in the US, where harsh working conditions have made the profession less appealing. With FSD, the Semi will be able to handle highway driving autonomously, reducing stress and fatigue-related accidents, while also optimizing delivery schedules. The environmental impact of the Semi is just as important. Although heavy-duty trucks make up only 1% of vehicles in the US, they account for 18% of greenhouse gas emissions. Saving 1 million gallons of diesel equates to cutting 22,400 tons of CO2, a significant contribution to the fight against climate change. The Semi's drag coefficient of 0.4, much lower than the typical 0.8 of traditional trucks, reduces charging needs and boosts energy efficiency. While the Tesla Semi holds enormous potential, several challenges still need to be addressed. The current megacharger infrastructure is limited to a few select locations, such as Tesla's factory and Frito-Lay's facility in Modesto. For the Semi to truly become a mainstream option for long-haul trucking, expanding the charging network is critical. However, the Biden administration's repeated refusal to fund the Charging Corridor project, combined with the strained relationship between Elon Musk and Donald Trump, raises questions about the future rollout pace of megacharger stations. In addition, although Tesla's new production line is optimized with automation and on-site battery manufacturing, it will still take time to refine and reach peak efficiency. The Tesla Semi clearly outperforms competitors like Volvo, Mercedes-Benz, PACCAR, Daimler, and BYD. No other electric truck matches its 500-mile range and impressive acceleration. Still, to dominate the market, Tesla will need to double its production capacity, aiming for 100,000 units per year, in order to compete with well-established names like Kenworth and Peterbilt. As Europe ramps up its transition to green energy, Elon Musk has confirmed plans to bring the Tesla Semi to the European market, with production to be launched at Giga Berlin. However, this won't happen in the short term, as Tesla still needs to fulfill orders from North American companies that have been waiting years to receive their semis. Expanding into Europe could be a major opportunity, as the Class 8 electric truck segment there is becoming increasingly competitive. With its superior technical specs, the Tesla Semi has the potential to become the new king of the electric truck market, not just in North America, but also across Europe. However, the road to bringing the Semi to Europe won't be easy, with several hurdles and regulatory challenges ahead. At the IAA Transportation 2024 Expo in Hanover, Tesla brought 2 Semis from the US, one for display and one for test drives, attracting significant attention from fleet operators. Dan Priestley emphasized that the Semi was designed from the ground up with multiple markets in mind, including Europe, with minor adjustments like wheel covers and signal lights to comply with local regulations. Still, the Semi's expected launch in Europe, likely no earlier than 2026, faces some major obstacles. Strict regulations around truck dimensions and weight in the EU are a key challenge. Currently, the Tesla Semi appears to exceed the maximum legal width, measuring 8.5 feet versus the 8.37 feet allowed in most European countries. Additionally, the European market tends to favor cab-over designs that maximize cargo space, while the Semi uses a traditional long-nose conventional design common in American trucks. This could require Tesla to make some design tweaks to better align with both regulatory standards and the practical needs of European freight operators. Beyond regulatory hurdles, the Semi's center driving position also represents a significant departure from European norms, where truck cabins typically place the driver on one side. This offset layout optimizes cabin space, forward visibility, and maneuverability when reversing or parking near the curb. To better suit the European market, the center seat design may need to be shifted to the left side, and a sleeper cabin would likely be required, as that's a standard feature for long-haul trucks in Europe. While Tesla has deployed megachargers at its Nevada factory and Frito-Lay's Modesto facility, the charging infrastructure in Europe remains in its early stages. Back in 2021, Tesla announced plans to build a dedicated megacharger network for the Semi in Europe, but so far those plans don't appear to have materialized. And as we all know, Tesla's service footprint in Europe is still relatively limited, especially when compared to the well-established service networks of major European commercial vehicle manufacturers, which can offer immediate support to fleet customers. Meanwhile, the electric truck market in Europe is growing rapidly and becoming increasingly competitive, with strong entries from major players like Volvo's FH Electric, Mercedes-Benz's e-Actros 600, and several others. Volvo has emerged as a leader in this space, with an estimated 3,000 electric trucks currently operating in Europe. This puts Tesla in a position where it must not only face a limited service network, but also directly compete with established players who have already built a strong presence in the market. Many also point out that Tesla has no competitive advantage in this market, given the particularly poor image Tesla has there, as evidenced by the constant disruptions at Giga Berlin. Therefore, in our view, bringing semi-trucks to Europe is a strategy that Tesla needs to consider very carefully. It holds significant potential, but also presents numerous challenges. On one hand, the Tesla Semi still holds a clear advantage, as no electric truck in Europe currently offers a range of 500 miles or an energy efficiency of 1.7 kilowatt-hours per mile like the Semi. The Volvo FH Electric only achieves 373 miles, while the Mercedes e-Actros 600 reaches 311 miles. Moreover, the full self-driving feature will take the Semi to a whole new level, reducing stress for drivers and addressing the labor shortage issue in the European transportation sector. However, before it can make an impact outside North America, Tesla will need to overcome not only design and regulatory barriers, but also build a strong service network and supporting infrastructure. The Tesla Semi is not just an ordinary electric truck. It represents a significant leap forward in the heavy-duty transportation industry. With production ramping up rapidly, Tesla is demonstrating a strong commitment to the success of the Semi, with aerial images showing bustling manufacturing activity, signaling that this revolutionary truck is soon to become a key player in the industry. As Tesla continues with mass production, the question is no longer whether the Tesla Semi can compete with diesel trucks, but when it will fully surpass them. The Tesla Semi is ready to change the landscape of the transportation sector. While some still mistakenly believe that the Tesla Semi is just another ordinary electric truck that can't compete with diesel trucks, the production delays are not a sign of failure, but rather a calculated strategy. The company needed time to gather real-world data from drivers to ensure that when the Semi enters mass production, it will not only be an ordinary electric truck, but a true revolution in the transportation industry. Those who think the Tesla Semi has no advantage over diesel trucks or other electric models have overlooked the clear benefits it offers. The numbers speak for themselves: lower operating costs, reduced maintenance, and superior economic benefits. The Tesla Semi is not just the future of transportation, it's also a smart investment for any business. While the initial purchase price may be higher than that of diesel trucks, the significantly lower operating costs save businesses hundreds of thousands of dollars each year, thanks to its superior energy efficiency and minimal maintenance costs. Cost savings are the most crucial factor making the Tesla Semi a worthwhile investment. With operating costs significantly lower than diesel trucks, businesses can save hundreds of thousands of dollars annually, which is incredibly important in the transportation industry, where every mile driven directly impacts profits. What do you think about Tesla Semi? Drop your views below. EV expert Sandy Munro once remarked that solid-state batteries are the kiss of death for gasoline and diesel, as they are the most promising type of battery capable of enabling EVs to reach up to 1,000 miles on a single charge. This also means they pose a serious threat to Tesla's 4680 battery, which is currently considered the best EV battery in the world. With the superior power of solid-state batteries, Toyota, as a pioneer in this technology, is confident it can surpass Tesla. The company boasts a 700-mile range and a full charge time of just 10 minutes. Toyota believes solid-state batteries will be a major breakthrough, making them more mainstream than Tesla's 4680 battery, and that Elon Musk will fall behind if he doesn't get on board with solid-state tech. However, in our opinion, despite their potential, solid-state batteries still face significant challenges. So the question remains, between Tesla's 4680 battery and Toyota's solid-state battery, who will be king? Tesla is rapidly ramping up production of the 4680 battery, currently manufacturing over 500,000 cells per day across its facilities. For now, with Toyota's solid-state battery still not widely available, the 4680 remains the best battery on the market exclusively from Tesla, with no serious competitor yet that truly worries Elon Musk. But that doesn't mean there's no reason for concern. Many other companies are proving strong results with solid-state batteries, including Samsung Solid Power and QuantumScape, and Toyota's solid-state battery is no exception. We believe it's important to first understand the basic concepts of these two types of batteries, as that's the root of the issue. We'll try to explain it as briefly as possible. Simply put, every EV battery consists of four main components: an anode, a cathode, a polymer-based separator, and an electrolyte. However, what makes solid-state batteries different from most current battery technologies and potentially revolutionary is that instead of using a liquid electrolyte, they use a solid one. Liquid electrolytes are found in all lithium-ion batteries, including the 4680. So essentially, that one change, the use of a solid electrolyte, completely transforms the nature of the battery. The 4680 battery was first announced by Elon Musk in September 2020, and to date, is only used in the Cybertruck. Fundamentally, the Tesla 4680 is still a cylindrical lithium-ion battery with a diameter of 46 millimeters and a height of 80 millimeters. Its cathode is primarily composed of nickel with 81.6%, the remaining 20% made up of manganese and cobalt. The anode uses silicon instead of graphite, and the cell's characteristics show very strong performance specs. The 4680 battery stands out not only for its optimal size and structure, but also for its innovative tabless design. This design eliminates the traditional tabs that connect the anode and cathode within the battery, offering a range of significant benefits. By doing so, the battery achieves higher energy density, reduced internal resistance, and a simplified manufacturing process, allowing Tesla to lower costs and boost performance. Meanwhile, today's solid-state batteries come in various shapes, including cylindrical, prismatic, pouch, and even thin film types for small devices like earbuds or smartwatches. However, the most common formats are prismatic and pouch cells, which optimize space in EVs and energy storage systems. Solid electrolytes in these batteries are primarily made from three main types of materials: oxides, sulfides, and polymers. So who will win the race for energy density? There's no denying that the competition around energy density is becoming increasingly fierce, with battery technologies constantly evolving to deliver more power in the same volume or weight. Higher energy density means a battery can store more energy, enabling electric vehicles to travel farther on a single charge, an essential factor in expanding EV driving range. The latest generation of Tesla's 4680 battery marks a major leap in energy density, reaching levels of 300 to 350 watt-hours per kilogram, compared to the traditional 2,170 lithium-ion batteries' 260 watt-hours per kilogram. This represents a 15 to 35% improvement in energy storage capacity. Thanks to its dry electrode manufacturing process, the 4680 not only boosts energy density, but also offers exceptional advantages in performance and production cost. According to Tesla, the 4680 battery can increase an EV's driving range by 16% thanks to its high energy density and tabless design, a significant improvement over traditional batteries. When combined with innovations like cell-to-chassis integration and advancements in battery pack design, the range can increase by another 14%, bringing the total range improvement to nearly 30% over conventional battery systems. A clear example of this is the Tesla Model 3. With a 75 kilowatt-hour battery pack, the sedan can reach a range of 363 miles and weighs about 4,000 pounds using traditional LFP batteries. However, with 46,080 cells, the range could increase to 471 miles, while the vehicle's weight drops to around 3,600 pounds. That's a major upgrade not only in range but also in overall performance and weight efficiency. While Tesla's 4680 battery is primarily focused on outperforming competitors in terms of efficiency, especially with its longer range and lighter weight, solid-state batteries come with an even greater ambition: to create electric vehicles with range equal to or even exceeding that of internal combustion engine vehicles. And in fact, this is not such a far-off goal. The energy density of solid-state batteries today is truly impressive. CATL, the world's leading battery manufacturer, has launched a solid-state battery with an energy density of up to 500 watt-hours per kilogram. Samsung reached a similar milestone earlier this year. In the US, Solid Power has made its mark with a solid-state battery based on a sulfide electrolyte, achieving 500 watt-hours per kilogram in a 100 amp-hour cell. This battery offers superior thermal stability and boosts energy storage by 50 to 75% compared to traditional lithium-ion batteries. One of the standout companies in this race is Toyota, as they plan to double the energy density of solid-state batteries compared to current lithium-ion models, aiming for 600 watt-hours per kilogram by 2026. If successful, Toyota's solid-state battery would have twice the energy density of Tesla's 4680, which would mean Toyota's EV range could potentially reach 750 miles, bringing them closer to reclaiming the lead from Tesla. Furthermore, recent sources indicate that Toyota plans to develop solid-state EV batteries with a range of up to 923 miles. If this becomes a reality, Tesla will face a significant challenge. With such outstanding energy density, solid-state batteries clearly have the potential to dominate the electric vehicle market in the future. However, it's important to note that higher energy density doesn't automatically mean faster charging times, an area where Tesla still leads with its fast-charging technology and manufacturing processes. So, how's the charging time? When it comes to charging speed, insiders at Toyota say their prototype solid-state battery has a clear advantage over current lithium-based batteries, able to charge from 0 to 80% in just 15 minutes. That means customer concerns about long charging times, sometimes stretching for hours, could soon be a thing of the past. The charging speed Toyota promises is nearly on par with the Shaanxi superfast LFP cells from CATL. Solid-state batteries use solid electrolytes made from metal oxides, metal sulfides, or solid polymers. Sulfides, in particular, are softer materials, and this softness plays a key role in allowing lithium ions to move more easily. Oxide-based electrolytes, on the other hand, can handle higher voltages, meaning they can push more ions through the electrolyte for better performance. However, Toyota's solid-state battery faces major challenges in achieving this fast charging speed. One of the biggest issues is dendrite formation, a serious problem that develops much more rapidly in solid-state batteries. Dendrites are branch-like structures that can grow between the battery's electrodes, potentially causing a short circuit. To this day, it remains somewhat of a mystery how soft lithium dendrites can pierce through what should be a hard, solid electrolyte layer. In simple terms, frequent fast charging can make solid-state batteries more prone to short circuits, causing performance degradation faster than conventional lithium batteries, which handle stable charging rates more reliably. So, is Tesla's 4680 battery the better option? With Tesla's 4680 battery, we've observed that both the anode and cathode use full polarity tabs. This design significantly shortens the path of current flow, allowing electrons to move more efficiently through the battery. As a result, the internal resistance of the 4680 battery is only 1/5 that of the 2170 battery. This means the 4680 charges significantly faster than the 2170. According to real-world testing, it takes just 20 minutes to charge the 4680 from 0 to 60%. When paired with an 800-volt electrical architecture, the charging speed improves even further. Currently, the Cybertruck uses 4680 batteries and can charge from 10% to 80% in just 30 minutes, despite having a massive 123 kilowatt-hour battery pack. Before the Cybertruck, some Tesla Model Y vehicles were also equipped with 4680 cells and showed impressive charging speeds. One owner reported driving their SUV to a supercharger station in California with 0 range remaining, and in just 32 minutes, the battery was charged up to 80% using a 250 kilowatt charger. There's no denying that solid-state batteries charge faster than Tesla's 4680. That alone could be enough to convince impatient EV drivers who don't want to wait around. However, that's not the whole story. Now let's talk about safety, because that's the question many people will ask. Which battery is safer for EVs? Tesla's 4680 battery is highly regarded for its safety, thanks to several standout features. First, its simple design eliminates tab connections, reducing the risk of short circuits and improving overall system stability. Second, the thicker steel casing offers better protection for the battery cells against impacts and vibrations, thereby increasing durability and safety. Finally, the 4680 battery's integrated cooling system helps regulate temperature effectively, minimizing the risk of fire or explosion. The clearest evidence of the 4680's safety is seen in Cybertruck accidents, where despite severe vehicle damage, Even near total destruction, the trucks rarely catch fire. However, since the 4680 still uses liquid electrolyte, it's not completely safe, especially when compared to solid-state batteries. Solid-state battery technology is praised by experts for its safety, as replacing the liquid electrolyte found in lithium-ion batteries with a solid one significantly reduces the risk of leakage. To put it simply, in lithium-ion batteries, the liquid electrolyte allows lithium ions to move between the positive and negative electrodes during charge and discharge cycles. But like any other liquid, this electrolyte layer is sensitive to temperature fluctuations. You may have seen batteries swell in the middle or even leak some electrolyte fluid, and that's really bad. If the electrolyte evaporates or leaks out, it can cause a short circuit between the positive and negative electrodes, potentially leading to a fire or explosion. If that starts happening underneath your car floor, you're in for a very bad day. So compared to the 4680 battery, solid-state batteries have a slight edge when it comes to safety. Don't get us wrong, both are considered safe, as each type of battery has its own unique design and safety systems to prevent failures. Even solid-state batteries aren't perfectly safe. If you're looking for a longer, lasting, and safer option, Tesla's 4680 battery actually has an advantage over solid-state batteries due to its more stable charging behavior and lower risk of dendrite formation. One of the downsides of solid-state batteries is their relatively short lifespan, and manufacturers are still working to improve the materials. Solid-state batteries still need further development to completely eliminate risks like thermal runaway under extreme conditions, such as temperatures over 300 degrees Celsius, or internal short circuits caused by dendrites. Even so, they pose far fewer risks than current battery technologies, and creating EVs that don't catch fire is a huge win for drivers. Toyota's solid-state batteries appear to have two strong advantages over Tesla's 4680 cells: energy density and charging time, both good enough to potentially lead the entire industry. However, the production cost of these batteries remains a nightmare for manufacturers, and that's one of the biggest obstacles preventing them from hitting the market. According to Toyota, they claim their solid-state batteries will have production costs that are 50% lower. But don't get me wrong, that doesn't mean they'll be 50% cheaper than today's lithium-ion batteries. It simply means they'll be 50% cheaper compared to Toyota's original cost estimates for producing solid-state batteries. As it stands, solid-state batteries can't compete with lithium-ion batteries when it comes to cost. The materials used in solid-state cells are extremely expensive. For example, lithium sulfide, a promising solid electrolyte, can cost 5 to 10 times more than lithium carbonate, not to mention the strict purity requirements for ceramic electrolytes, which further complicate and drive up the cost of manufacturing compared to current battery technologies. To bring solid-state batteries to market, companies must solve not only performance challenges, but also rebuild the entire battery production ecosystem. While Toyota claims it can cut production costs in half, that doesn't mean solid-state batteries will be half the price of current lithium-ion packs. In reality, producing them requires extremely controlled environments, dry rooms, and strict humidity controls, which add significant costs to assembly. The second major barrier is mass production capability. Creating a thin and uniform, solid electrolyte layer is a significant technical challenge. Most major companies like Toyota and QuantumScape have only seen promising results at the lab or prototype stage. A stable, large-scale manufacturing process has yet to be achieved, and any defect during assembly could pose safety risks or severely impact battery performance. The third challenge is durability. Some solid-state battery prototypes currently last only around 1,000 charge cycles, while commercial products are expected to last several thousand. On top of that, there's the issue of dendrites, lithium crystals that can grow through the solid electrolyte and cause short circuits. Even though solid-state batteries are generally considered safer, dendrites remain a major concern, especially when using lithium metal anodes. Finally, material compatibility is another significant hurdle. Not all current cathode materials work well with solid electrolytes. This means companies might need to redesign electrodes or develop entirely new materials, which could lengthen development timelines and increase costs. While solid-state batteries hold massive potential, they still face serious challenges in terms of cost and manufacturability. Meanwhile, Tesla's 4680 battery, as mentioned earlier, is already being produced at scale, with over 500,000 cells reportedly manufactured daily across its facilities. This suggests the production lines for the 4680 are relatively efficient. Currently, Tesla is only using the 4680 in the Cybertruck, and the truck's performance has been genuinely impressive. That said, it's still unclear why Tesla hasn't extended 4680 use to its other vehicle models. What's your take on that? Although Tesla hasn't disclosed the exact production cost of the 4680, analysts estimate the current price ranges between $114 and $170 per kilowatt hour. Elon Musk has stated a future goal of scaling 4680 production up to 1,000 gigawatt hours per year, with costs potentially dropping to $70 per kilowatt hour, an ambitious but bold target. Tesla continues to push aggressively toward this goal and has already achieved an impressive rate of progress. In conclusion, both solid-state batteries and Tesla's 4680 cells are revolutionary technologies that are pushing the EV industry forward. Solid-state batteries, with their superior energy density, fast charging capability, and enhanced safety, have captured the attention of both manufacturers and consumers. This technology is widely seen as the future of EVs, especially because it addresses key safety concerns associated with lithium-ion batteries, such as fires caused by liquid electrolytes. However, high production costs, a lack of standardized raw materials, and complex manufacturing processes remain major hurdles. For now, solid-state batteries are mostly limited to high-end EVs. On the other hand, Tesla's 4680 battery, while not yet reaching the energy density breakthroughs of solid-state tech, stands out as one of the most advanced and practical batteries currently available. Tesla is rapidly scaling up production of the 4680, aiming to lower costs and increase volume, a strategy that helps the company maintain its leadership in the EV market. The Tesla dog robot project has been hyped up for a while, and Elon Musk finally confirmed on X that Tesla dog is being tested at Giga, Texas with a bunch of useful tasks following Optimus. Alongside the humanoid Optimus robot, Tesla's gearing up to drop a dog robot with some pretty cool features, like a way to stop vandals and attackers targeting Tesla stores by Musk haters. It hasn't officially launched yet, but the Tesla dog robot's already got some jaw-dropping features and tech. Way more than we expected, at least 6 of them. If Tesla starts selling this dog robot, we're betting it'll keep your house safe as hell. Of course, Tesla's not the first to make a dog robot. Other companies like Boston Dynamics with their Spot Dog or Unitree's Go 2 are already out there. So Elon's not just trying to compete. Building the Tesla dog is a must for his big picture vision. The timing's no coincidence either. Tesla's been dealing with a ton of vandalism at their stores, and Tesla cars keep getting torched. Price-wise, the Tesla dog might only cost about a quarter of what Optimus does since it's got way fewer parts. Musk said the Tesla bot, Optimus, runs $20,000 to $30,000, so the dog robot could be around $5,000. That's cheap enough for pretty much anyone to grab one. Alright, so what's the deal with Tesla's dog robot? What features does it have, and how did Tesla build it? As Elon confirmed back in May, he's sticking with Tesla for at least another 5 years, which means the attacks on Tesla and its products aren't slowing down anytime soon. Recent clashes between Elon Musk and Trump have only made things messier. Okay, believe it or not, the Tesla dog robot project has been in the works since Elon first planned to launch Optimus. Back then, Boston Dynamics was stealing the show with their Spot Dog, built to handle all sorts of environments, from industrial sites to research and rescue missions. But instead of jumping on that bandwagon, Tesla focused on Optimus first. Why? Because Elon figured if they could nail a humanoid robot like Optimus, adapting that tech to make a dog robot would be a piece of cake. Basically, it's way easier to transfer tech from a human-shaped robot to a dog bot than the other way around. Put simply, the Tesla dog robot will use the same drivetrain, battery, joints, sensors, and AI system found in Optimus, but in a more simplified form. As Elon Musk explained, to bring robot production costs down as much as possible, Tesla has heavily reused engineering from its electric vehicles for Optimus, and now from Optimus to the Tesla dog.
Everything we've developed for our cars, the batteries, power electronics, the advanced motors, gearboxes, the software, the the AI inference computer, it all actually applies to a humanoid robot.
Elon Musk's goal is to create a robot dog that's not only smart, but also more agile and significantly more affordable, like we mentioned earlier, around just $5,000. Yeah, compared to other robot dogs like Boston Dynamics Spot or the Unitree Go 2, the Tesla dog is truly much more budget-friendly. Looking at Boston Dynamics Spot, although it has proven useful in tasks like safety inspections and industrial monitoring, it still has some major limitations. With a price tag of up to $74,500, limited battery life, and less than ideal performance in highly intelligent tasks, Spot doesn't quite meet all the demands one would expect from a true robotic dog. Meanwhile, the Unitree Go 2 can perform tricks like waving, jumping, and flipping, but its real-world interaction capabilities are still limited. It can't automatically wake up when needed or carry out tasks like patrolling or surveillance without human intervention. Looking at the Tesla dog, it grabs your attention right off the bat with its sleek, modern look. Unlike those clunky robots that seem like a bunch of metal parts slapped together, Tesla dog's got a clean, polished vibe that keeps its weight low and makes it super easy to move around in any setting. If you've followed Tesla's product design over the years, you'll notice everything they make. EVs, humanoid robots, or this dog bot has that super minimalist style. But don't get it twisted. Minimalist doesn't mean cheap or rough. Even when you put a Tesla car or robot next to its competitors, Tesla's stuff always stands out as the sharpest. Based on the info we've got, the Tesla dog robot comes in at a solid 40 inches long, 19.2 inches wide, and 25 inches tall when it's on the move. Compared to Boston Dynamics Spot Dog, which clocks in at 43.3 inches long, 19.7 inches wide, and 24 inches high, the two are pretty close in size. Sure, the Tesla dog is a bit shorter, but that's actually a win. It lets the robot dodge obstacles like a pro and makes it a better fit for tight spots like homes, retail stores, offices, or cramped factory floors. Sources from the Tesla dog robot engineering team revealed that Elon Musk specifically requested the robot's weight be optimized as much as possible, from 90 pounds down to just 65 pounds, including the battery. According to Musk, the Tesla robot dog strikes an ideal balance between agility and stability on uneven terrain. This makes it especially well-suited for use in Tesla stores. A lighter weight allows for smoother movement, but the robot must still be heavy enough to remain stable and avoid losing balance while traversing obstacles. Tesla dog comes in two colors, black and white, just like the Optimus robot. It's also built using high-end composite materials, with an aluminum frame covered by a plastic shell. This provides outstanding durability while keeping it lightweight. That not only makes it easier to operate, but also ensures long-term reliability. More importantly, a simple, intuitive design that's easy to mass-produce is a top priority for Elon Musk with this project. So, what do you think of the Tesla dog robot's design? Surprisingly, Tesla dog actually has a head that resembles a real dog. If you've seen the Unitree Go 2, you might have noticed its head looks a bit strange, and Boston Dynamics Spot doesn't even have a head. Tesla's decision to give the robot a dog-like head makes it feel more friendly and approachable. At least, your kids won't be scared when you bring a robot dog home. With Optimus, most people said it moves quite slowly, only about 1.2 meters per second, which is partly due to its 138-pound weight. However, Tesla dog stands out not just for its sturdy design, but also for its superior mobility compared to competitors. It's equipped with flexible joints powered by ultra-compact, integrated actuators. The robot dog's legs allow for smooth movement, making it easy to change direction and navigate obstacles. With a top speed of 1.8 meters per second, Tesla dog is actually faster than both the Unitree Go 2 with 1.5 meters per second and Boston Dynamics Spot with 1.6 meters per second. Tesla dog's eyes come equipped with a high-res 2D camera, delivering a full 360-degree view with a range of up to 20 feet. This lets Tesla dog not only map its surroundings with pinpoint accuracy, but also optimize its movement and navigation. The camera system works reliably even in low-light conditions, ensuring top performance around the clock. Tesla has a proven track record of building cutting-edge sensor systems, and Tesla dog is no exception. Like the Optimus robot, Tesla dog is decked out with full-body sensors from head to toe. These sensors don't just spot obstacles and prevent collisions, they also maintain safe distances for smooth, precise movement. What sets Tesla Dog apart, though, is its thermal sensors. These can detect heat sources, like human or animal bodies, even in complete darkness or dim environments. This isn't just a nice aim-to-have feature, it's a practical necessity, since most break-ins at Tesla stores happen at night. With this capability, Tesla Dog can spot intruders and sound the alarm in real time, boosting property protection and ensuring security during critical situations. Packing Tesla Robot Dog with a ton of sensors makes it a game-changer for tasks like nighttime patrolling or standing guard, taking over jobs humans would usually handle. Some reports even say its AI, paired with a speaker system, lets Tesla Dog pick up sounds beyond just commands. Think fire alarms, cries for help, or signs of an attack. Built with top-notch materials, Tesla Dog boasts an IP60 rating, meaning it can shrug off dusty environments without a hitch. It's also tough enough to handle extreme temperatures, from -4 degrees Fahrenheit to 131 degrees Fahrenheit, making it insanely durable in harsh conditions. Tesla Dog runs on a 1.2 kilowatt-hour battery pack, powering it for 6 to 8 hours of continuous use, depending on the task. That's a big leap over Boston Dynamics Spot, which taps out at about 2 hours. With Tesla Dog, you get long-lasting performance without the constant need to recharge, perfect for extended missions. With its 1.2 kilowatt-hour battery, Tesla Dog doesn't just optimize performance, it keeps things lightweight, making it super agile. Compared to Tesla's humanoid Optimus robot, which rocks a 2.3 kilowatt-hour battery, Tesla Dog's smaller pack ensures nimble movement without sacrificing range. For tasks like patrolling or light navigation, it can run for up to 7 hours straight without a hiccup. And like Optimus, it supports wireless self-charging through custom docking stations, so you can skip the hassle of plugging it in every time. Tesla Dog's AI, trained on Tesla's beastly Dojo supercomputer, uses the same deep learning algorithms as their self-driving cars. Its brain has been fed thousands of real-world images and data, letting it map environments, identify objects, and analyze human or animal behavior. It can spot intruders nearing key areas like Tesla dealerships, recognize faces, and even detect weapons that might be used for vandalism. After analyzing behavior, Tesla Dog can record and send instant alerts to security teams. On top of that, as we mentioned earlier, Tesla Dog can recognize voices and sounds, letting it process complex commands and respond accurately and fast. Don't get it twisted. It can't talk like Optimus since it doesn't have Grok voice, but it can understand instructions and react efficiently. Tesla Dog's 2D camera doesn't just let it see its surroundings, it records continuously, day or night. Paired with its thermal and audio sensors, it can pick up odd movements or sounds like breaking glass or sneaky footsteps, triggering instant security alerts or sounding an alarm automatically. This capability doesn't just protect property, it keeps security staff safer, especially in tense or dangerous situations. With its quick reactions, Tesla Dog helps cut risks and shields people in scenarios where lives could be on the line. That said, everything we know about Tesla Dog so far comes from leaked info by folks close to the project. Tesla might make plenty of tweaks and upgrades before officially launching Tesla Dog next year. For now, Tesla's focus and resources in 2025 are zeroed in on cranking out Tesla Optimus, aiming to produce at least 5,000 units as Elon Musk has claimed. Now we'd like to briefly talk about Optimus, since Tesla is planning to release it next year, and many customers are starting to ask questions about the Tesla bot's ability to take on a wide range of tasks. Unlike traditional robots that require pre-programming or remote control, Tesla's Optimus has the ability to learn in ways we've never seen before. With the capability to watch instructional videos on YouTube, this robot can learn up to 100 new tasks per day, from simple chores, like sweeping the floor or doing the dishes, to more complex skills like operating machinery or cooking a delicious meal. For example, to learn how to make a sunny-side-up egg, Optimus just needs to watch a chef on YouTube prepare the ingredients, turn on the stove, and crack an egg into the pan. It will observe the process a few times, try it out itself, and gradually adjust its technique to get near-perfect results. This learning process may take only a few minutes for simple tasks, or a few hours for more complicated ones. but it's still hundreds of times faster than traditional robot training methods. This capability not only offers unprecedented flexibility, but also makes Optimus a powerful assistant across a wide range of settings, from the home to industrial environments. What truly sets Optimus apart is its ability to learn directly from humans. No programming skills or specialized equipment required. This approach makes Optimus more user-friendly and accessible than ever before. You don't have to be a tech engineer. Anyone from stay-at-home parents and factory workers to retail employees can become a trainer for Optimus. This opens up limitless potential for its applications, from assisting with household chores to optimizing production processes in factories. One of Optimus's most groundbreaking features is its collaborative learning system. When one Optimus learns a new skill, it uploads that knowledge to Tesla's shared software network. Instantly, every other Optimus around the world can access and perform that same task without having to learn it from scratch. Just imagine, if an Optimus in a California factory learns how to assemble an electric vehicle component, every Optimus in Shanghai or Berlin will be able to do the same thing in a matter of seconds. This system creates a collaborative learning network, allowing the entire fleet of robots to improve at an exponential rate. If Tesla deploys 1,000 Optimus robots, and each one learns a new task every day, the system could accumulate 1,000 new skills daily, rapidly, building a massive skill library. This not only makes Optimus more efficient, but also enables it to take on complex tasks like synchronizing movements for group dances, a clear demonstration of the system's consistency and intelligence. In the service industry, Optimus could take on roles as an intelligent sales associate, assisting customers in real time, or work in restaurants handling serving and cleaning tasks. In agriculture, it could plant seeds, water crops, harvest produce, and monitor plant health. These capabilities not only boost productivity, but also reduce reliance on manual labor, delivering significant economic benefits. According to a recent report by Morgan Stanley, replacing just 10% of Tesla's workforce with Optimus could save the company $2.5 billion. Each robot has an estimated net present value of $200,000, highlighting the massive economic potential of Optimus. In the service industry, a restaurant using Optimus could significantly cut labor costs by having the robot serve food, clean up, or assist in the kitchen. In manufacturing, Optimus could boost productivity by 20 to 30% thanks to its ability to work 24/7 with high precision, while also lowering maintenance and training expenses. Elon Musk envisions Optimus as a mass-market product with an affordable price. He estimates that the retail price of Optimus will range from $20,000 to $30,000 once large-scale production is underway, significantly cheaper than other humanoid robots like Boston, Dynamics, Atlas, or Figure AI's Figure 02, which typically cost over $100,000. However, some sources suggest the initial price in 2026 could be higher, around $40,000 to $50,000, due to production costs and supply chain challenges, particularly for components imported from China. Tesla aims to reach the $20,000 price point once annual production hits 1 million units. Tesla also plans to offer an Optimus rental service, allowing users to experience the robot at a lower cost. While the official rental price hasn't been announced, some speculation on X suggests it could be around $400 per month. This is a smart strategy to make Optimus more accessible and encourage users to try it before committing to a purchase. As impressive as Optimus's rapid learning capabilities are, they also raise important safety concerns. What happens if the robot accesses videos that teach dangerous skills, like using weapons or committing acts of sabotage? To address this, Tesla will need to implement advanced AI filters to screen video content before Optimus learns from it. Videos containing keywords like weapons or violence would be blocked based on both contextual and visual analysis. Additionally, Tesla could restrict the sources Optimus is allowed to learn from, for example, limiting it to official YouTube channels, Tesla's proprietary training materials, or pre-approved user-submitted content. In a market crowded with humanoid robots, Tesla's Optimus stands out with its unprecedented learning capabilities and its role as a true household assistant. With the ability to learn 100 tasks per day from YouTube, Optimus not only outpaces its competitors but also redefines how we think about automation. From assisting with household chores and revolutionizing manufacturing to enabling entirely new business models, Optimus is on track to become one of Tesla's most iconic products. While it still requires time to be fully refined and is expected to launch in the third quarter of 2026, Optimus has already proven that the future of humanoid robotics isn't just intelligent, it's genuinely useful. Above all, both the Tesla Dog robot and Optimus are very exciting. Will you buy them? Drop a comment below. Thanks for watching, goodbye, and see you again.